Hey everyone, Fraser here. I'm back from my hiatus. 3 weeks in Australia. I had an amazing time. Big thanks to everyone at Star Stuff for hosting me, letting me talk in front of hundreds of people. I had a really good time. But that meant that the newsletter didn't happen while I was gone. But I'm back now, answering your questions. So as always, this is a question show just for the people who are subscribed to this newsletter. So if you are reading any of the current news stories and an idea pops into your head, you got a question, just hit reply to the email and I will gather a bunch of them up and I will answer them here and publish them. All right, let's get on with it. If I remember how to still do this. All right, Tommy Vask asks, hey Fraser, if you haven't done so already, would you mind showing us how the Earth and Sun would look seen from James Webb Space Telescope's future vantage point or vantage orbit around the Earth-Sun L2? I'm most curious about how much of the Sun will be visible there. And Tommy, I'm just going to leave this screen up for a second, and you can see that the distance from the Earth to the Sun is 150 million kilometers, while the distance from the Earth to the L2 point is only 1.5 million kilometers. So what that means really is that the distance of the James Webb, which is going to be flying out to that L2 Lagrange point, is only 1% farther away than the distance from the Earth to the Sun. So the Sun is going to look essentially exactly the same size as it does in the sky, and especially when you consider that the distance that the Earth goes to around the Sun, it moves closer and farther in its orbit because its orbit is a little bit elliptical. So actually, the Sun will look exactly the same size in the sky, and James Webb will need to avoid it in order to not be able to see it. So it's not that much of a problem. All right, next question. This is hard. Okay, here we go. Ben Russ, what do you think of the new Oxford study saying that there's up to a 99.6% chance that we are alone in the galaxy? Part of the conspiracy to keep the truth from us? Ben Russ. Right, so we've actually been reporting on bits and pieces of this for several weeks in the newsletter. I kind of feel like we were one of the first people to break the news. If you go back, if you've been getting these newsletters for a while, we had a story on that. And the gist was a bunch of researchers had developed a new model, and based on their calculations, it seemed possible, 66% I believe was the number that they got, that we were the only advanced civilization in the observable universe. And you know, does this math check out or not? We don't know. The problem is that we only have one observation. We only see that there's life here on Earth. We haven't found life on Mars. We haven't found life on the Moon, Titan. We haven't seen signals from any other world. So really, the Drake equation, this revision to the Drake equation, anyone who attempts to estimate how much life there is in the universe just can't go any further than, we don't know, right? We know that life was able to form here on Earth. We know that life was able to form the moment, pretty much, life could form on Earth. That's pretty weird. And yet, the universe is big and old, and life could and should have formed many times in the past, and yet we don't see it. So really, until we find evidence of life on any other world, we're not going to be able to really predict what we're going to be able to find out there in the universe. It sucks, but that's why we need to go looking. All right, let's move on. Come on. Next one. That's not it. This one? Okay. James, so organic molecules have been found on lots of places in the solar system. Now, most recently, the complex molecules Curiosity found, and in the Chrysers, is that a word that I made up in a previous video? I think it's a word that I stole in a previous video, on Enceladus. What are some examples of simple and complex organic molecules and some everyday objects that would contain these molecules to help me get a better understanding of what they are? Like carbon is used every day in diamonds or graphite in my pencil. Thanks, James. Right, so this was about a month ago. There was some even more complex organic molecules found on the surface of Ceres, which is the largest asteroid and it's a dwarf planet. And those molecules, and a lot of the organic molecules that they're finding out there are, oh man, I forget the name I had before prepared. Apologies. They're a kind of hydrocarbon. So oil would be an example, but not oil exactly, like benzene, things that would burn and sort of create a sooty tar-like substance is sort of the kind that they're finding. So think about things that would burn like that, but not from an organic, not say from trees or dead dinosaurs, but in this case other ways that those molecules could have formed. The kinds of things you would find on Titan as well. All right, next one. Stephen Thomas, here's a question. Why is there so much radiation around Jupiter? Is it simply due to its gravity? That's a great question. Now, we've talked about the magnetosphere that surrounds the Earth and also surrounds Jupiter. And this is this sort of region of trapped radioactive particles streaming from the sun. So the sun puts out solar wind. These particles are dangerous and sort of high energy particles, and Earth and Jupiter capture these with their magnetospheres and then hold on to them and sort of orbit them around and around and around. And this is why the Van Allen belts here in around Earth are dangerous, and you want to get through them very quickly. And the ones around Jupiter are even more dangerous and stronger. And why? It's because Jupiter has a much stronger magnetosphere and is able to capture more of these particles than the Earth can. And what causes the magnetosphere? I mean, astronomers are still trying to work it out, but it's this metallic hydrogen. On Jupiter, even though it's made of hydrogen, as you go down into Jupiter, the hydrogen is pushed into higher and higher temperature and density and begins to act like a metal under this really high density. And there's various parts of Jupiter that are spinning at different speeds than other parts, and this creates this dynamo like we have here on Earth, but with Earth it's our metal core. On Jupiter, it's this metallic hydrogen core that creates these really powerful magnetic fields that trap all this hydrogen. And so if you try to spend any time anywhere near Jupiter, you're going to be bathing in this radiation. So Jupiter's a very dangerous place to be near, and this is why scientists have to really be very protective of any spacecraft that are going to be flying to Jupiter, because it's so dangerous there. All right, next one. Michael. I'm so frustrated that this bloody James Webb that I've been waiting for years. I really believe that this new telescope will help us discover things that might change our understanding of the universe and maybe even find biomarkers in the atmospheres of exoplanets. I really hope that this is the last time they postpone the launch. Michael. I understand your frustration, of course. James Webb should have launched close to a decade ago and should have only cost a couple of $1 billion, and now it's already passed $8 billion, and it's probably going to add another $1 billion plus on top of that when it's finally done and launched. The Ariane 5 rocket that was supposed to carry it has been retired. It's like the last Ariane 5 that they're going to be using, and if they wait any longer, then Arianespace isn't going to have the right facilities to launch it. So there's a bunch of reasons why the delays of the James Webb Space Telescope are frustrating. I totally get that. That said, this is a really big, complicated, advanced telescope where they had to develop entirely new science on many cases and new techniques that had never been considered before. This whole sunshade, the folding mirrors, there's a bunch of just brand new technologies that are going into James Webb. And any time that you develop new technologies, you have these kinds of challenges. Would it have made more sense to have launched a bunch of Hubble Space Telescopes as opposed to James Webb? Maybe. There's a lot of people that make that argument, right? Hubble is dramatically oversubscribed right now. A lot of people are waiting to use it. If there was 2, 3, 4 Hubbles, you could probably fill up all of that telescope time as well, and astronomers would be really happy. At the same time, James Webb is going to be able to answer these fundamental questions. It's going to be able to look right out and see the first galaxies forming. It's going to be able to detect the atmospheres of extrasolar planets. So it's a very important telescope, and who knows? At this point, NASA's done a really comprehensive study. They think that it's going to be ready for, I think, 2021 now, and this is fairly independent, and I feel pretty confident with this latest estimate. I don't think we're going to see a lot more delays. This was a chance that all of the sort of hidden unknowns got pushed out into the sunlight, and I think at this point we feel a lot more confident about that 2021, but we'll see what happens. It's sometimes you don't know whether things were good ideas until after you proceed on them, and then you find out if it was a good idea or it turned out to be more complicated. But you can't know until you start, and that's the thing, is that it's like inventing light bulbs, right? You try 100 different versions that don't work until you find the one that did. And so I think that James Webb is worth and was worth embarking on, and we'll see what happens. I believe those are all the questions that I had queued up. No, I got one more. All right. My question, when will the Earth be a flat Earth? Roughly speaking, we have the sun getting old and frying us, Andromeda crashing into us, proton decay, all doom and gloom, the universe is expanding, the event horizon is getting closer. At some point, the event horizon will be the size of the Earth, making it to the locals flat. So the Flat Earth Society will be right, or will this ever happen? Steve from London. I see what you're saying, and I don't think what's going to happen is what you think is going to happen, apart from a lot of those other things. So the Earth isn't growing. And so I can imagine sort of what you're saying, right, is that if the Earth was expanding as the universe was expanding, right now we could measure the curvature of the Earth, and then maybe billions, trillions of years from now, the Earth would be so large, the curvature on the Earth would be impossible to detect, and so it would feel like it was a flat surface. But the reality is that the Earth isn't expanding, right? The Earth is staying exactly the same size, and that's because the gravitational force that holds the Earth together is more powerful than the expansive force that is pushing the universe apart. And this is why you're going to hold together, and the Earth is going to hold together in its same shape, and the solar system is going to hold together, and the Milky Way is going to hold together. It's only when you get those vast distances in between galaxy clusters that that expansive force of dark energy is pushing more than the inward force is pulling the galaxies and galaxy clusters together. So there's some perfect spot where, yes, indeed, future galaxy clusters are going to get pulled apart and they'll never be able to make their way together. But on a local level, nothing's going to be expanding. All right, well, those are all the questions that I had this week. Again, if you're reading this newsletter and a question pops into your brain, whether it's about one of the stories in the newsletter this week or today, or you've been reading a piece of space science news and you just want to ask a question about it, just go ahead, reply to the email when you get it, and I will gather a bunch of them up and I will answer them here. All right, well, thanks, everyone. We'll see you next week.